Okay, I've got the top of the hour on my clock, so we're going to get started so we can make sure we can get through everything today. You want to say welcome. Hello, everyone. Thank you for joining me today. I hope you're all having a good day so far. And so the topic of today's webinar is going to be about protecting slopes against the forces of nature using the GEOWEB 3D cellular confinement system. So I'm your host, Sam Justice, and I'm a licensed professional engineer in the state of Wisconsin and Kentucky, and I have degrees in civil and geotechnical engineering. So I'm one of the engineers here at Presto Geo Systems, and we manufacture erosion control, stormwater management, and porous pavement products. So all of our products are made in the upper Midwest of the United States, so they are Buy America approved. And then we have an extensive national and international distribution network. So that's how you would actually get the material from Wisconsin to wherever your project is. And so we do offer technical and site support, as well as a free project design evaluation from our in-house engineering team, which I am a part of. So just a little bit about so here are some of the things that I hope you get out of today's presentation. So some learning objectives. So understand the causes of surface erosion, which is kind of what we're focusing on today, and learn about how the GeoWeb system can help improve that and protect against those different types of erosive forces. You can see how flexible and versatile the GeoWeb system is, and just how well the system can work on a wide variety of projects, even very steep slopes. And just so everyone is aware, this presentation is about slope surface erosion only. So we're not going to be talking about global stability issues or how to repair large deep-seated failures. So if you are concerned about that type of failure or that type of solution, we do have a solution for that we're just not covering today. So feel free to reach out with any of those type of questions. More than happy to talk about them. So everybody is muted today, but if you do have questions during the presentation, please type them in your questions tab in your GoToWebinar menu. I'll see those, and then once the presentation is over, we will do a quick Q&A session and try and go over some of those questions you may have. So a little bit of background about Presto Geo Systems. So we worked with the U.S. Army Corps of Engineers to develop the Geocell technology in the late 1970s, and we've been innovating in this market ever since. So our products have been used in over 200 countries and in every state in the United States. And we go beyond simply providing a product. We're helping you provide a complete stabilizing solution for your project. And like I mentioned, we work in 3 different main product areas. The first being soil stabilization, and this uses our GeoWeb Geocells. And those can be for load support, so vehicle access, slope and channel surface protection, and then constructing retaining walls. And we're going to be focusing on that slope protection aspect today. Then we also operate in a porous pavement market, where you have both a vegetated and a stone surface solution, and then also lightweight and reusable construction mats, so something that might replace something like timber matting. So like I said, today we're focusing on slope protection using the GeoWeb system, but if you do have questions about any of our other products or any of our other types of areas that we work in, definitely reach out. More than happy to talk about it. Okay, so this is going to probably be background for everybody, but I just want to start with a really quick overview of the broad classes of slope failure that the GeoWeb system can help repair. So the first and probably the most obvious cause of soil erosion is water movement. So high intensity rainfall events and then their resulting runoff can easily strip the soil from a slope surface. But global failure can also occur if your pore pressures elevate and change the properties of your soil particles, so reducing that inner particle strength. Again, not talking about global failures and solutions today, but definitely something to consider when you know you have a very saturated environment. You can also have water flowing through the slope. We see this really often in dam embankments or along channels, anywhere that you have high amounts of water pressure, you'll see something like this, the piping failures issues. Then you can also just have water flowing down the face of the slope. You're going to cause rills and gullies. This is probably one of the most common things that you'll see. And this is a great thing that the GeoWeb system can fix, is to really prevent this sort of failure. And then also sort of a specialized focus is going to be things like shoreline erosion. And this is where you have that sort of continuous water movement, either flowing through a river, or if you're along a lake or even a coastline where you might have wave action, and you have this continual erosion of your shoreline, the GeoWeb system can be placed and try and help prevent that type of failure. And then finally, one that I want to talk about, it's not technically considered erosion, but it is the misapplication or the failure of erosion control blankets, turf reinforcement mats. It's pretty much any type of geosynthetic or geotextile that might have been placed along the surface. If you have that type of failure, you really can't just replace it, because otherwise it wouldn't have failed in the first place. So putting the GeoWeb system in to fix these type of failures is also definitely an option. Okay, so like I said, super simplified, a little bit of background, but just so we all have the types of failures in our minds. So now we're going to talk more about the actual GeoWeb systems. This is our product, and it's going to be what we use to provide our solutions for these types of failures. So the GeoWeb system consists of two main attributes. The first is going to be the cell or the container size. So the cells come in 3 diameters, small, medium, and large, and then they come in heights between 3 and 12 inches. So 5 different options that you can choose there for how deep the cell is. So the cell aperture, so the cell opening and height, are going to be project dependent, which one you're going to choose, and they're going to be selected following an evaluation of your project specific needs and your site conditions. So there's no one right answer. Can't always say you want the medium size that's 3 inches deep. You're going to have to choose which one is appropriate for your specific project. And then something else that I kind of want to point out while we're looking at this is going to be the ultrasonically welded seam. That's going to be all of these connecting points. And basically, I want to point out that the stronger the seam strength, the better the performance of the Geocell. So a strong seam allows for heavier infill material, steeper and taller slopes, and better overall lifetime performance. So the GeoWeb system is produced using a high-quality virgin high-density polyethylene, HDPE. And so this provides consistently strong welds at each cell junction, while also maintaining semi-rigid ductile properties within the cell walls, and has high stress crack resistance, overall toughness, and long-term durability in any environment. So it's not necessarily super important that you remember each one of those specific terms, but just know that we decided to use virgin HDPE as opposed to adding fillers or exotic polymer blends, because to do that actually ultimately will reduce your weld strength and will reduce your environmental stress crack resistance. And that's basically meaning that your Geocell would not perform as well. There are some competing Geocell products out there on the market that do add fillers or use polymer blends, and they do this in the name of increasing the cell wall stiffness. So they're trying to focus on a single property within the Geocell that they're trying to improve, but it actually leads to detrimental effects to other properties within the Geocell. So something that we want to point out, and I'm going to say it a lot here in the beginning, is about uniformity within the Geocell. You want a uniform performance across all of the different elements of a Geocell system, rather than focusing on just a single element alone. So just something to keep in mind, you really want to have that word floating in the back of your brain, uniform, uniformity in the performance of the Geocell. So the second main attribute, I said that there were two for the Geocell system, is going to be the actual infill material. So now this is, you have the first attribute, which is the actual material itself, making all of those containers. And now it's going to be about what you put into those containers. So an important benefit of the GeoWeb system is that even low quality aggregates, sandy materials, and even salvaged materials, so Site 1 materials, can be used as the infill. So you have a lot of flexibility. Using those salvaged stone or sand materials can save a lot of money in material and hauling costs if you are in a remote location and it would be expensive to truck something in. Another option is to actually eliminate or significantly reduce the fines content of a aggregate blend. And you can do this because the GeoWeb system actually provides the apparent cohesion that those fines content would give to the stone. So you can reduce or eliminate the fines, which would then allow for more water movement. So if you're looking for something more porous, this would kind of be the way to go. And you're still getting the strength of that stone infill, but you don't have to worry about those fines clogging up all of the pores. So this is all just basically to say you don't have to use those really expensive engineered stone blends if you don't want to. And this is something that, using the 3D GeoWeb system is sort of separate than how a planar geogrid would be. Geogrids typically require, engineered stone with a pretty high friction angle to lock in and hold everything in place. And you just don't need that with the GeoWeb system. So just something to keep in mind if you're trying to compare those different solution options. But all of that to say, we've got our three options here on the screen. You've got your aggregate, which can be stone or sand or salvaged material. You can do topsoil, and this is going to help you grow vegetation. And then you can also do concrete. So basically 3 categories of options there. So here is just a standard performance and material specification summary. So this is something that's offered with all of our products. So we pack a lot of information onto this one sheet. And I'm not going to go through every single line today because that would be a lot. But basically, this is what you should get a sense of what you would expect to see if you were to spec a Geocell into your project. So there's a lot of detail on different key material properties, such as that weld strength and that environmental stress crack resistance that I mentioned before. And so just as sort of a general note, when you are reviewing specification sheets, you really want to pay attention to see if there's any sort of disclaimer language or, that fine print that somebody might sneak into the bottom. And so you just want to make sure that, the data that's shown here is what it is saying, and it's not just sort of trying to play tricks on you, not trying to use, those weasel words to be like, oh no, we're definitely good enough sometimes. Our products are always going to meet these specifications, and you're not going to see things like specifications are subject to change without notice, or information shown is for general purposes and not intended for design. Those are the types of things that you really want to look out for, because it could potentially mean that the material is not going to perform the way you would expect it to. So basically, our spec sheet contains no disclaimers, and we're going to stand behind all of these numbers so that you can deliver certainty in the solution while you build with materials that you can trust. Okay, so that's the actual GeoWeb panels, is what they're called. So it's a panel of all of those different containers all welded together. And you also are going to have additional system components. So system components are going to be all of the supporting pieces that help the GeoWeb system protect your slope surface. And again, ensure that uniform performance, uniform, keep that word in mind. And so it's going to protect against things like non-uniform deformation. It's going to protect against that erosion that we're trying to focus on, all of those different things. So I've got a really simplified diagram here to show all of the different system components and how they interact with the GeoWeb panels to form that complete system. And we're going to talk about all of these in a little more detail, but basically, so you've got your slope here, some standard dimensions. First thing, you may need to put a geosynthetic down. This could be something like a geotextile, maybe you have a geomembrane, anything along those lines that might be necessary for your specific project. It's not always required, but it is sometimes. Then you're going to put the GeoWeb panels down. They'd go either directly on that geosynthetic layer or onto just the slope surface if you don't need that. And so what we're also going to point out is that there's that horizontal turn at the top of the GeoWeb panels. So this is important for crest anchorage and erosion control. I'm going to talk about that more. So we have two options for anchoring. The first is to use stakes or things like earth anchors, pins, that sort of thing. And so these are placed along the mid-slope and at the crest. And the number and spacing of the stakes is going to be project dependent. The other option, so you would do one or the other here. So the other option would be to use a tendon and crest anchorage system. And crest anchorage could be, probably the most common would be a dead man anchor. So you would bury that in a anchor trench, that sort of thing. You could also use earth or rock anchors or tie off to existing infrastructure. You just need some sort of crest anchorage. But then you fill in the GeoWeb material with your desired infill. If you're going for vegetation, we typically do recommend something like an erosion control blanket on top. So that's basically what the system would look like on your slope face in a quick nutshell. So thinking back a couple slides, the GeoWeb panels do come in discrete sections. The panel size is around 250 square feet. Your project is probably bigger than that. So multiple panels are going to be required. So we have the Atra key. And so this is our first component of that completely integrated system. It's connecting all of those individual panels of GeoWeb into a single web that's going to cover your entire project site. And it does allow for faster installation of the GeoWeb system, and it's going to last the lifetime of the project, ensuring that the slope is protected and that the GeoWeb system isn't going to fail under anticipated loads. And so the specific engineering properties of the Atra key will ensure that the system holds up to loading over time, and it's not going to corrode like you would with metal staples, and you're not going to see things like failure of underperforming cable tie systems. And we again have a specification sheet that calls out those specific engineering values for this patented connector. So now we're going to talk about anchorage. I mentioned there were two different options. Option one is using stake anchorage. So if the GeoWeb panels were to be completely flat, you don't really need to use anchorage. Gravity's doing the work. But we're not talking about flat today. We're talking about slopes. So as your slope angle increases, the driving force of the infill will exceed the available frictional resisting force of your slope. So you need anchorage. So for shallow slopes, and generally 2 to 1 or less, or 2 to 1 or shallower, so about 26 degrees, stake anchorage is usually going to be sufficient. So we have two options for stakes. One is made of the standard steel rebar, and the other is made of that high density polyethylene, HDPE. And that's what's shown in the photo on the left here. So if you are in a potentially damaging environment, so if you were in a saline environment, like along a coastline, the HDPE speed stakes are going to be a lifesaver compared to corrosion-prone steel. And the stakes can easily be driven by hand or by a power drill for easy installation. So the other option for anchorage is going to be to use a tendon system. And this is going to be for areas with steep slopes. So it's going to be steeper than a 2 to 1 slope. If your slope is highly erodible if you've got like a really broken shale that you would just damage by driving stakes into, or if your surface just can't be punctured at all. If you've got a waterproof geomembrane liner, you obviously don't want to be driving stakes through that. So those are some scenarios where the tendon system might be appropriate. So we have a specially designed Atra tendon clip, which transfers the load from your infill material to the tendons and then up to the Crest Anchorage system that I mentioned before. And that Crest Anchorage system is, again, going to be really project dependent, but that's something we can help you determine is what's going to be most appropriate. So only the Atra tendon clip is specifically designed to fully and safely transfer forces placed upon a geocell. There's no other product like this on the market that's going to do the work that it needs to. You can't just tie the tendon in a knot and hope that works. That's just not going to be sufficient. And so this sort of goes for all of our different accessories. Every accessory we have and every feature has been designed and tested specifically to work together so that we can go from problem to design to construction solution with a system that's actually going to be able to support real world forces and not just, hypotheticals. So just something to keep in mind. And so just sort of the benefit of using a GEOWEB system is that it really prevents significant movement of the soil by containing that soil within those individual cells of the GEOWEB panel. And so by separating the soil into these smaller segments rather than a large mass, the system resists mobilization of the entire slope face due to hydraulic loads. And so that's really how it's preventing that erosion. It's really allowing the water flow to just flow right over the top without picking up and moving the soil so that it's not causing those rills and gullies to form. And it is important to reiterate that the proper installation of the GEOWEB system includes that horizontal embedment of the GEOWEB into the crest of the slope. This prevents water from flowing beneath the GEOWEB system and undermining it. So you're not going to see rills or gullies forming underneath the panels that could potentially lead to failure. The system provides a way to fully vegetate slope surfaces that otherwise couldn't support sustainable plant life, and increases the overall slope stability by interlocking with the vegetated root zone. And stone and concrete materials can also be confined on within the GEOWEB panels on slopes that would be normally too steep. The stone would just slump all to the toe of the slope, not with the GEOWEB panels. I will say vegetated slopes, so with the topsoil and then growing grass, are going to be the most popular option for slope protection because they do result in a more attractive slope and there's little to no maintenance required. So always a positive. But hard armor, so stone or concrete infill, is definitely an option. And they can be installed in areas where, where you have really an arid environment, so you're not seeing a lot of rainfall, so vegetation might not grow. Or if you know that you need to collect your water from the slope and take it somewhere else, doing a concrete infill might be the way to go with that. So that's definitely an option. Definitely don't want to discourage you from that if it's going to be most appropriate from your project site. But yeah, vegetation probably the most common. And then this is just a non-exhaustive but short little list of some of the typical project applications we see that utilize the GEOWEB solution for slope protection. So it does give a pretty good idea of the range of the system. So anything from a typical cut and fill embankment to landfill linings, dam faces, anything like that. We've probably covered it. We've been doing this for about 40 years now. I've seen a lot of different projects, and always happy to help you determine the best solution for your specific project. So with that background, we're going to move to something a little more interesting. Everybody likes to see case studies. They like to see how these sorts of things actually work in the real world. So let's start with those vegetated slopes. They are the most common. So This was a vegetated slope over an unstable soil slope at an active gold mine up in Canada. So it had variable lengths along the slope, variable heights, variable slope face angles. So this was not a uniform site. This had a lot of different flexibility on site that needed to be covered. Additionally, an access road was going to be built at the top of the slope where you see that excavator. So the slope had to be stable enough to support the expected traffic live load. So a lot of different things needed to happen here. And they were able to use the GEOWEB system, fill it in with topsoil. You can see the grass growing in that bottom right-hand photo. And they didn't have to come in, they didn't have to regrade the slope. They were able to keep all of that different flexibility. This really worked out well for them at this active site. This is another one along that same area, so that it was in northern Canada. But one of the things to highlight here is when you have space restrictions. So what if you can't regrade your slope to something shallower that might be more stable? So when you have things like roads at the top, you've got other existing infrastructure, bridge abutments, that sort of thing, is that you can still use the GEOWEB system around that existing infrastructure. You don't have to regrade the slope or anything like that, and you can integrate it to what's already there. And this is really great on steeper slopes. That's where people start seeing a lot of issues. The GEOWEB solution is great because it can still fit around guardrails at the crest. You can put in fencing, you can put in other infrastructure that's necessary. None of it's going to negatively impact the of the GEOWEB system. So this next one's a really common application. Road embankment repairs. So this is, you're constantly seeing soil or stone wash out onto your roads, potentially closing lanes, just causing headaches for everybody. So by covering the slope with the GEOWEB system, and then you fill it in with topsoil, let it grow, get that nice vegetation in there. Now you don't have to have the concern of constantly replacing the soil after storm events. You don't have to constantly come in and clean off the road, that sort of thing. And this is where we would typically recommend some sort of surface protection. So something like hydro seeding or biodegradable erosion control blankets. So you would place those over the top of the GEOWEB system once you've filled it in with that topsoil. And that's to help hold the soil in while the vegetation grows. So it gives you a little bit of extra time before that grass comes in, and that can help resist the water flow. Having hydro seeding or an ECB on top is a good temporary measure. So embankments along roadways obviously have to deal with some pretty significant sheet flow off of your impervious roadway surfaces. So this was a project for the Maryland State Highway Administration. So sheet flow had actually caused some pretty significant sloughing of large sections of the upper topsoil layer. And it was causing those rills and gullies, and it was happening so frequently that they couldn't establish any vegetation to try and prevent it. So by using the GEOWEB system, that was able to hold the soil in place while that vegetation started to grow, so that it could resist that sheet flow. So when you have these areas of just continuous sheet flow where you just aren't getting that vegetation to grow, the GEOWEB solution is a great way to come in and give that vegetation a little extra time to fully root in and be able to stay in place. So road widening is also becoming a lot more common. The departments of transportations are trying to find more roadway space without displacing, structures, people's homes, that sort of thing. So slopes or embankments are usually where that extra space can be found. And so this was a road widening project in New Hampshire. So the GEOWEB Slope Protection System allows for those steeper slopes to be created without erosion concerns. And the system can be installed quickly and then vegetated really quickly so that there isn't a long construction time that might shut down those important roads. And so ease and speed of construction are definitely some important features of the GEOWEB system that everybody appreciates. So this was another one, but this is a great overhead shot of the GeoWeb system being installed on a slope. And again, you can see the variability of the slope in terms of height, slope angle, slope length, all of those different things. And this one even had a large boulder that they ended up leaving in place on the right-hand side of the slope there. And it doesn't actually cause a significant interruption of the GeoWeb system. You can just sort of place the GeoWeb panels around that, whether it's a boulder or something like a bridge abutment or some other structure that you might need to leave in place. So this one actually ended up using a tendon system. You can't quite tell from the photo here, but just so that you have an idea, something like this, a tendon system, is probably more common than using those pins or those stakes. Let's see. And then this was just how it looks when it's finished. And so I just want to point out that you aren't going to see that black plastic. Once the vegetation's fully grown in, no one is really going to be able to tell that anything except grass is there. So in terms of aesthetics or anything like that, you don't have to worry about it. The grass is going to fully grow in, cover any of the GeoWeb material that you might see during installation, and it's just going to look like a nice green vegetated slope. Okay, so another case study. So this one was actually along a shoreline. This was in the Chicago Botanical Gardens. And so this was going to also be a vegetated system, but it had to deal with water movement, in this case, really small wave action, but still wave action. And so this was actually kind of interesting. They went through, de-watered the pond where this was. And they can do that because it was at the Botanical Garden, so it's a sort of maintained pond, but they were able to de-water it so they could do everything in a dry environment. You don't necessarily have to do that. You can work in a wet environment if you don't have dewatering capabilities, but I'm sure it makes your crews happier not to have to stand in water to do that. And so, like I said, they put in the sheet piles. You can see them there to de-water. Because this was both a really sort of narrow, it's a very small slope, and then also you can see it's a pretty shallow slope. They were able to use stake anchorage. And so that is a little bit faster sometimes, especially when it's a really small area like this. The stakes might go in a little quicker than a tendon system. So something to consider. And then the GeoWeb was actually filled in with native soil from the pond. And then the same plants in this botanical garden were placed in there to try and grow. So this would end up being a seamless look overall. And so you can not see it here. So this is actually, you can see where the GeoWeb was placed, and you're not going to see it. You're not going to have any idea that it's there. So now there's this thriving water garden in place. And the workers at the Botanical Garden don't have to worry about further erosion of that stream bank. They don't have to worry about it potentially undermining. You can see a little concrete retaining wall there that they don't have to worry about anymore. So now this is just something that they have this peace of mind that is going to stay this beautiful garden without a lot of maintenance necessary. And then a sort of different thing that I want to highlight, I mentioned it a little bit before, was geomembrane liner protection. So if you are over a landfill, if you're doing some sort of collection or detention pond, that sort of thing, you're going to have a liner that you don't want to puncture. In this case, it was actually a highway cut that exposed a pyrite-bearing sandstone to air and rain, creating the potential for acid rock damage. So pretty specific to this case, but again, needs that impervious geomembrane liner over the top to prevent that water interaction. And then they needed to protect that liner. Geomembrane liners are really thin. They have an easy potential to tear, especially if they were to be impacted by a rock or anything like that. So the GeoWeb system actually rests directly on top of the geomembrane liner, and then it was anchored with a tendon system. So you're not having anything along the slope face that's going to puncture it. This is, like I said, a great way to cover landfills. drainage ponds, anything where you don't want maybe chemicals leaching into the groundwater system, that sort of thing. So definitely an option if you're just looking to protect your liner. You don't necessarily need slope erosion protection, but you need liner protection. And then I do want to point out that the GeoWeb system can actually handle incredibly steep slopes. You know, we're sort of talking generally in the less than 1-to-1, so about 45 degrees or less. But if you do have steeper slopes, it's definitely possible. So this was a project along the Pan American Highway in southern Peru, where the slope on each one of these terraces was actually about 1/4-to-1. It comes out to about 75 degrees. So this was a really unique project. Obviously, you're not seeing something like this every day. These terraces were actually hand compacted at that angle, so they're not natural slopes. And because of that, they were able to confirm that the slopes, each one of those terraces, was globally stable in a way that a 75-degree slope normally wouldn't be. But this is why the GEOWEB Slope Protection System works, because the slopes were internally stable on their own, and they just needed that surface protection. And because of how steep they were, they needed a lot of anchorage. It's pretty hard to hold soil at that angle. So there were a lot of tendons that were put in. You can see those being put through each of the GeoWeb panels there. And then they actually had individual anchor trenches at the top of each terrace. And this was something that they decided to do. They had a additional geogrid layer underneath the GeoWeb panels. That's definitely a very project-specific thing, but just to let you know that it is possible if you do have project-specific needs for that geotextile, geogrid, geomembrane liner underneath the GeoWeb system, definitely possible. And then here's what it looks like. This was about 6 months later, vegetation fully established, and these terraces are still in place. Now, even at these really extreme angles, the GeoWeb system can be a great part of your solution. So just, wow, I think it's kind of cool. Okay, so like I said, that was vegetation. Vegetation, probably the most common application, but aggregate using stone is definitely possible. So it can provide a great low maintenance solution. It's really good for areas where vegetation might not grow easily, or if you're just in an area where stone is really common, it's something you could easily salvage on site. It does allow for water infiltration. So if you are collecting sheet runoff from a road, it could be a great way to do that if you don't have to, store that water somewhere else. If you just want it to infiltrate into your groundwater system, definitely an option. So this case study, this was going to be a steep slope, and it was actually adjacent to a railroad track. So the vegetation on this slope wasn't enough to hold the slope in place, and it actually all sort of slumped to the bottom and is covering the railroad tracks in this photo. And obviously, whenever tracks are down like that, railroads are ready to go. They want it fixed as soon as possible, the fastest possible solution for them. So with the GeoWeb system, they were able to come up with this really quick solution. They stripped all of the vegetation from this failure area, and they actually did a little bit of regrading with a spider excavator, which is maybe one of the coolest pieces of construction equipment I've ever seen. It just hangs off the side of the slope like that. I think it's really neat. In this case, they also decided to use a non-woven geotextile over the freshly regraded slope. They did this because they were going to use stone infill. And that's sort of something that why you may use a geotextile underneath the system if you have two very different materials. So a stone infill and a soft soil slope are going to be very different materials. And so having a geotextile sort of as a separation layer can be a benefit to make sure you don't have mixing of those two materials. If you have soil infill and a soil slope, two really compatible things, you don't necessarily need that separation layer. So we can go into more detail about why you may or may not want a geotextile, on a project-specific basis, or if somebody has a question about it, I might talk about it later. But just as a general idea, if you want that separation, geotextile might be the way to go. And so with this, you can actually see how the GeoWeb panels come. They come sort of squished together, and then they open up like an accordion. And so you can actually thread those tendons through the unexpanded sections, and that makes it really easy installation. And then you tie off those tendons to some version of a Crest anchorage. And a single worker can carry that unexpanded section of a GeoWeb panel. So that makes it really easy to get everything in place without having to do a lot of on-slope work. And so you can actually then sort of just drape the GeoWeb panels over the slope face. You would have the Atra tendon clips. We talked about those before. Those are what are connecting the tendons to the GeoWeb panels to the Crest anchorage. And you can, again, do this on the crest of the slope, so you don't necessarily have to have a guy hanging off the slope like this, but it's sort of whatever works for you, however your contractor feels comfortable. And then those GeoWeb panels are going to get connected with the Atra key. We talked about those earlier. So again, that's going to connect all of the individual panels to make one uniform, cohesive system. They were able to use a man lift in this case to make it a little safer, and also this pretty steep slope, can't just walk on it. If it's a shallower slope, you absolutely can walk between all of these GeoWeb cells. You can step in between each one and do the work that way. Then filling in with stone, we typically recommend filling from top to bottom rather than from bottom to top. And this just ensures that you're not putting excess weight on the bottom of the panel first. Could potentially damage the system. It's just easier to go from top to bottom. And then this was the final solution. So this was a permeable aggregate slope. The railroad wouldn't have to do any further maintenance on this slope. They don't have to come in and maintain that vegetation or anything. The stone is just going to stay in place. Water is going to be able to flow over the top of it without dragging the stone down to the toe. So all good in terms of what is required in maintenance. If things like volunteer vegetation, so if like weeds or anything start growing on the slope, it's possible, but it's not going to negatively affect how the system works. So you can remove them if you don't like the look, but if a dandelion starts growing in the middle of the slope, it's kind of no big deal. So for this one, the Minnesota DOT used the GeoWeb system to help stabilize the surface around bridge abutments. And then also along the railroad tracks and road crossings. And so the flexible nature of the GeoWeb panels means that it's easy to contour to your slope face and then also around those structures such as a bridge abutment, So with the system in place, water erosion is prevented around those abutments, so you don't have to come back and worry about exposed concrete or anything and have to constantly replace the soil around those abutments. And in this case, the project was actually a mixture of topsoil and aggregate. The aggregate was used underneath the bridge where it was in shade, so vegetation wouldn't grow. And then out in the open, they actually allowed for topsoil and vegetation growth to have that more natural look. So you can definitely mix infills back and forth to be, what your project needs. It doesn't have to just be one or the other. And then you can actually even do aggregate and concrete as well. So this was also in the Chicago area, but they needed to actually capture some of the water runoff. So they had a concrete section where the water would flow to, and the water could then be captured, put in a stormwater retention basin, and then, done whatever they needed to. But then they had stone around the rest of it because it was a little bit cheaper, a little bit easier to install. So by having the flexibility of what infill materials you choose, also just makes it, more appropriate for your project. Again, not just a one size fits all, is what is most appropriate for any one specific project. And then the last infill type is concrete. So concrete, again, it's not going to be permeable like stone, but it's still considered a hard armor solution. But there's still going to be no maintenance requirements with concrete, and the embankments are going to be able to handle really significant amounts of water runoff. And that's kind of going to be the big focus of why you may choose concrete over stone or soil, is if you know you're going to have a lot of water movement. So the GeoWeb panels actually act as the formwork for the concrete, and then actually also as the internal reinforcement. So you don't need forms to be built, and you don't need things like rebar or fiber reinforcement within the concrete. Everything's handled by the GeoWeb panels. So the concrete is poured directly into the cells of the GeoWeb panels. And this also is going to ensure that you have a consistent concrete depth, because it's going to be screed right to the top of the GeoWeb panel, so you're not going to have variable depths. And it's not going to allow the concrete to slump to the toe. That's the big issue with pouring concrete on a slope, is how do you have that flexibility of, well, you need a little bit more water to make sure it actually flows, but it can't be too wet, because otherwise it's all going to slump to the bottom. With the GeoWeb system, that's not a concern. You can actually have a little more water within your concrete, and it'll still be contained within the GeoWeb cells and not slump to the bottom. This was going to be a channel project. This was down in Laredo, Texas, at an intermodal yard. And so the GeoWeb system actually replaced a design that they had, which called for 6-inch reinforced concrete channels and then 4-inch deep grout bags on top of that concrete on the side slopes. That's a lot. That's a pretty thick design. It would take a lot to build, to construct. It was going to be really expensive. So the GeoWeb system was actually a value engineered solution due to cost overruns. And so they were able to go with a little bit thinner of a concrete section. So rather than 6 inches of reinforced, they were able to do 4 inches of GeoWeb on these side slopes. And it ended up being that the GeoWeb system saved the owner of this intermodal yard a couple $1 million. Nothing to sneeze at. But also it sped up construction and allowed the yard to be in service much quicker than was initially planned. So definitely also great benefits. So like I said, the side slopes used much thinner concrete than was initially required. And because they were relatively flat and they're pretty short slopes, they were able to use stake anchorage. And then the bottom of the channel where the concrete truck is in this photo actually also ended up being a vehicle access road. And so they actually ended up driving vehicles on the concrete-filled GeoWeb, which is something we definitely didn't talk about today, but is a huge benefit of the GeoWeb system, is that it can support vehicle loads in areas that might otherwise not be able to. So it's another little bit of that flexibility and versatility of the GeoWeb system. More than happy to talk about it if anybody has any questions. So like I said, that those GeoWeb panels act as your form for the concrete, so you don't need to build any, which can be tricky on slopes. And so the concrete is poured from the crest to the toe, and each one of those individual cells holds the concrete in place. And then you screed the concrete flush to the top of the GeoWeb cells, so you get that nice consistent depth. And pore water pressure buildup is always a concern underneath concrete structures. So we typically will recommend either some sort of drainage pipe be included, or drilling weep holes through the set concrete to help relieve that pressure so that you don't get failure under the scenario. Either one, totally able to be integrated into the GeoWeb system, no concerns there. And so then this was the full extent of the project. It was at over 1 million square feet of GeoWeb panels, which is pretty significant. That's definitely not a small project. So definitely able to handle some very large applications with the GEOWEB system. So just a little bit of a summary here. GEOWEB has a great flexibility of design, has the variety of infills that you can choose to meet your specific project needs, including mixing infills if that's what's appropriate. Really steep slopes are not out of the question, even where otherwise you might have thought, there's just no way vegetation is going to grow here. It can with the GEOWEB system. And this is a complete system solution. So this is ease of installation, peace of mind. This has everything you need to make sure your project is going to be successful. And so every project is different, but Presto has a solution that's going to be right for you. So the GeoWeb system can be added to projects for a more stable, longer lasting, and flexible system. And we can do that with the project designs that we offer. And so these are going to be recommendations of a GeoWeb system, including panel size, the depth of the cells. There are a couple different depths to choose from. We can help recommend which one's going to be most appropriate. It's also going to be, it's going to give you everything that you need. And it allows us to work closely with engineers, contractors, landscape architects, owners, whoever, to be able to make sure we get something that's going to be appropriate for your project. And so the form for this evaluation is on our website, prestogeo.com. So you fill it out with as much information as you have. You can attach things like geotechnical reports, project site photos, anything like that. And then it comes directly to myself and the rest of the engineering team here at Presto. And then we can get directly in contact with you. And like I said, it's going to be within about, we say 3 business days, but it's usually a lot faster than that. Usually it's about 1 business day. We're going to provide this complete evaluation. It's going to have anchorage requirements, whether or not you may need that geotextile separation layer underneath the panels, anything that you might need to be able to put the GeoWeb system into your project, the evaluation would provide for you. And then just a quick recap, here's our specification sheet again. So we deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our specifications so you can deliver certainty and build with materials that you can trust. No disclaimers, no concerning fine print. And then this is just one of those things where one of the biggest questions we get is cost. No surprise there, especially if this is a new technology for you or your area. Just having a basic idea of how much the GeoWeb system costs compared with other stabilizing techniques, it can be really important. It can really tell you whether or not this is something that you're going to be able to consider. So this is just a really basic comparison for the GeoWeb system compared to a completely unreinforced section, something using a geogrid, and then using the GeoWeb system. And so this is for a load support application, not necessarily for a slope, but still kind of gives you the idea of the different costs. And one of the things you can see is how much thinner the GeoWeb section is going to be than either of the others. So you're definitely saving on the amount of materials that you need. And then just overall total cost per square yard is significantly lower than if you were to use a geogrid system per se. And then you can make that cost be even less if you use that salvaged material, if you're able to use on-site, site one materials. So costs may vary. This is really just a quick overview. But if there are any questions about how this sort of thing works, happy to talk. So there's the spec sheet again. But basically a little bit of housekeeping because I am done now. So housekeeping, we are making it faster and easier for you to obtain your PDH certificates, which you've earned by watching the webinar today. So with our webinar dashboard, you can easily view our library of webinars and download any PDH certificates for on-demand webinars that you've completed. So your webinar dashboard will keep a record of which webinars you've watched. And so in 2 to 3 days, you'll receive an email from Presto Geosystems with information on how to access the webinar dashboard, along with some other helpful resources, such as our library of other videos that we have. We have case studies and photos, that sort of thing is all going to be on there. So by the end of the week, look for that email from Presto Geosystems. If you watched the webinar live today, you're automatically going to receive your PDH credit. And this is going to come from GoToWebinar. It's not going to come from Presto Geosystems. It's going to come from GoToWebinar. So maybe check your spam folder if you don't see it, but you'll get that certificate automatically. You don't need to fill anything out if you watched this live. So with that little bit of housekeeping, that's my show for today. My contact info is here on the screen. I definitely say feel free to reach out to me or through our website. We have a contact us form on our website if you have any questions about what we covered today, if you have any projects that you want to talk about. Even in very, very early, just concept stages, we're more than happy to discuss how the GeoWeb system might be the right solution for you. With that, I've done pretty well on time today. So if you do need to go, I appreciate you staying with me, and hopefully you learned a little bit of something. I am going to do a little bit of a Q&A. Some good questions look like they've come in through the questions tab, so I'm going to go over those. The webinar has been recorded today, and it will include the Q&A session in the recording. So if you aren't able to stay live for the Q&A session, feel free to look us up on that webinar dashboard, email coming in 2 to 3 days, and you can basically skip to the end and hear the Q&A session that way as well. So with that, let's see what some good questions are here. Let's see. So is there a way to eliminate the need for anchorage, either using stakes or a tendon? You have certain, this person asked specifically if you design terraces at regular heights, but if you have certain conditions, is there a way to not have to use anchorage? The answer is maybe. So it depends on what the slope geometry comes out to be as to whether or not anchorage is going to be necessary. But if you do have, those flat, terrace sections, and then, a small slope, and then another flat section, terrace, that sort of thing, it's possible that you wouldn't need to use, some sort of heavy anchorage system. Maybe you could get away with just a little bit. That would definitely be something that we would have to look at very specifically for your project. There's not a way to say yes or no, 100% of the time, but it is a possibility if you are trying not to have that anchored system and you want to utilize instead flat areas. It is a possibility, yeah. So there was a question about specifying GeoWeb on a slope that failed due to hurricane flood damage. So that's definitely something that a lot of people are sort of running into, not necessarily hurricanes, but that extreme weather, whether it is hurricanes, whether it's just more damaging storm events. The climate is climate change is a thing right now, and so yeah, the GeoWeb system can actually be a pretty good solution for repairing and preventing future damage due to extreme weather events. You'd have to see whether or not the slope, if it had already failed, why did it fail? Was it just the high winds? Was it a more global failure or not? If it was a global failure, we might need to start talking about putting in the GeoWeb as more of a retaining wall rather than just a surface protection solution. We didn't talk about retaining walls today, but we have a lot of good information on our website and on the webinar dashboard talking about retaining walls and how those can be a good repair solution. So I would definitely sort of point us in that direction. But yeah, the GeoWeb system is a great way to try and sort of reinforce your slopes against erosion under these more extreme conditions that maybe we weren't used to. You know, a lot of people are seeing 100-year and 500-year storm events that you have to start, you know, preparing for. And the GEOWEB solution is a great way to try and, you know, meet those more extreme conditions. Good question about the type of vegetation that you put in the GEOWEB system. So that's a great question. I did just say, you know, it's soil with vegetation. So typically we do recommend putting in things like grasses or flowering vegetation, something that's going to have a really thick root zone, because that really helps hold everything in place, make sure that it's going to be a good sort of, you know, long-lasting project. And obviously you want something that's local to you. You know, you're not going to get Kentucky bluegrass to grow in the desert. So you want something that you know is going to grow in your climate. But if you want some larger vegetation, if you're hoping for you know, something like larger shrubs or even trees, something like that, it is possible to plant that type of vegetation with the GeoWeb protecting your slope face. Takes a little bit more effort, but definitely is possible. We've seen it happen. It ends up looking very beautiful. And really the thing is, you just sort of have to know where you would want to plant those, because you would need to open up the GeoWeb panels a little bit to make sure that they could accommodate like the trunk of a tree. Those cells, each of those containers, small, medium, and large, you know, have obviously their defined opening. And if you're going to have something larger than that, an oak tree is going to be potentially quite, you know, thick around once it grows. You just have to make sure that the GeoWeb panels are able to accommodate that. So it is possible to grow trees and large shrubs, and we have details available if you are curious how that sort of thing happens. So definitely feel free to reach out if that's something that you are looking at. Some other questions. What is the product made of, and how does it fit into some Buy America requirements? So the products, all of our products are made with virgin high density polyethylene, HDPE. So these are not recycled materials, they are virgin resin. And that allows for that uniform performance, really make sure that the material is going to meet the specifications that we say it does. All of our products are manufactured in either the state of Wisconsin or Illinois. The resin, I guess I can't say specifically where every batch of resin comes from, but it is shipped to us typically from the Gulf region, and then all of the material from that is manufactured in the United States. So it does meet Buy America requirements, which is typically needed on like federal contracts, that sort of thing. So all of that, you know, the extrusion, the molding, the cutting of perforations, the welding of those seams, all of that stuff is done in the US with American manufacturers. So great question though. Questions about potentially using a geosynthetic underneath the GeoWeb. So this can definitely be you know, a point of contention, especially if you are trying to grow vegetation. You wouldn't want to put a separation layer in. That would just be sort of stunting the root growth. And so I mentioned it briefly, but it was mostly the idea that if you have very disparate materials, if you're putting in a stone in as the infill and you have a soil slope, that's when a geosynthetic, typically a geotextile, may be required. It's not always, but it's definitely something that you might want to look into. If you have like a really clay slope, that could potentially cause issues with a geotextile. Clay obviously can get really slick once it gets wet. It also has the potential to clog geotextiles, really just get in there and just cover all of the perforations. And so that's something that we would want to look at specifically is, you know, you have a clay soil, do you need that geotextile, or can we get away with it so that we don't introduce basically a point of failure? We don't want to have that failure sliding plane. And so this is why we say it is project dependent. There's no one size fits all, but there are definitely times when a geotextile is necessary and a lot of times when it's not. So good question. I've gone over my time, so I'm just going to do one more question. So it was a question about during installation. I mentioned you could actually walk along the slope to help do the installation. You don't necessarily need to be on a man lift or anything like that. And the question is sort of how do you do that without damaging it? And so you would actually step into each of the individual cells, and the things like the Atra keys or the Atra tendon clips, the tendons, that sort of thing, you wouldn't be stepping on those. Those would be sort of right up against the GEOWEB panels. And so when you step into the center of a cell, you wouldn't be damaging anything. You don't want to step on the panels when they're empty, because you could potentially then damage the cells. But once they're filled in with soil or stone, you can walk across them, you can drive across them, no issues there. You know, you're not going to cause damage once they're filled in. So hopefully that answers that question. But yeah, it's definitely part of installation to say you can walk through the system as long as you're not directly on top of it until it's all filled in. Okay, I have gone over my time. I appreciate anybody that has stuck with me. I hope you've learned something. If I didn't get to your question, or if you think of another one in the future, please feel free to reach out. I am always happy to talk about new projects. Either myself or the rest of the engineering team here would be able to help you. I hope we see you in future webinars. Look out for those. You'll see notifications from our team about any future webinars that may be happening, and then definitely sign up for that webinar dashboard and watch some of the ones we've done in the past. So I hope you all have a great day, and we'll hear from you soon. Bye.